In this assignment here, it is a worksheet like you did last week where you type it in, and if it turns green, you did it right, and if it stays red, you did it wrong. So these are actually even the same problems from last week as well. So I have H2, N2, or N2 plus H2 equals NH3. So I know I needed to put a 2 here last week, and then I had to put a 3 here, and then this has to be 1. And you do have to put in the 1s if you want the full credit on it. It won't turn green without those 1s there. Alright, so then the next thing it asks you for is the molar mass, and it asks you for the molar mass of every compound, even though you're actually only going to use the molar mass of one of these compounds. But it's good practice. So for nitrogen, N2, you go to the periodic table, nitrogen is 14.01, and 14.01 times 2 is 28.02. No units, just type it in as the number. It'll stay red if you type in the units. And then the molar mass of hydrogen is 1.01, so this is 2.02. Again, no units. And then NH3 is 14.01 plus 3.03, which would be 17.04. Alright, and then when those turn all green, then you can go on to the problem. So this worksheet is actually, even though it says mole to mass, it's actually a mix of last week's mole to mass and this week's mass to mole. So those are two very similar kind of problems, so they're kind of mixed together on this problem, with this worksheet. So this first problem here, you are doing, like last week, a mole to mass problem. So they give you 4.5 moles of nitrogen gas, and they're reacting with excess hydrogen gas. Whenever anything says excess, it just means it's there's enough of it. It's not going to stop you from, continuing the reaction, but you don't need to do any math with that. And then how many grams of ammonia are formed, and down here in each problem I would write if there's something that maybe they didn't label. So nitrogen gas is N2, ammonia is NH3. So I start with my 4.5 moles of nitrogen gas. So let me actually do this here. So start with 4.5 moles of nitrogen gas, which is N2. Draw your division bar. Take your starting unit, moles of N2, and put it on the bottom. And then I'm going to be converting into moles of the other thing that they asked me for, which was, I think it was ammonia, yes, which is NH3. So the top here should be NH3. Now I have moles over moles, so this is where I go to the equation. So the NH3 has a 2 in front of it, and N2 is a 1. So 1, and this one was 2. Second division bar, top unit always goes on the bottom. Moles of NH3 down here, and they want me to convert into mass, so that would be grams of NH3. Whenever grams and moles are together, this mole is always 1. This grams comes from getting the molar mass, but we already did that, so it's right here, 17.04. So I'm going to put in the 17.04, and then I solve. So I'm going to take my calculator, I'm going to put in my 4.5, multiply by the top, 2, and then divide by the bottom, but it's a 1, so it's going to stay the same, it's going to stay 9. And then the next thing is multiply by 17.04 and divide by 1. So multiply by 17.04, actually 17.04, and then divide by 1, but that's going to give you the same answer. So I have 153.36. So let's go to the worksheet here, and let's put this in. So we started with 4.5 moles of N2. We put our moles of N2 on the bottom, and it was 1 mole of N2. 1 mole of N2. And then on the top, we put 2 moles of NH3. So 2 mole NH3. That was the first division bar. Now let's go back. So in the next one, we had 17.04 grams of NH3 on the top. And then on the bottom, it was the 1 mole of NH3. And notice how everything, I clicked the wrong thing. Notice how everything turned green, so I know that I have those in the right place. If something stays red, then you put that in the wrong place. So then the answer was 153.36. 153.36 type that in, and it turned green. So let's see if I can round. So if I did 153.4, would it take that? No. So you want to put in the exact answer that the calculator gives you, 153.36, and then the unit for that should be the same as this top unit here. It also should be the same thing as what they asked you for, which was how many grams of ammonia. So this should be grams of NH3. Oh, sorry, I clicked moles of NH3. Grams of NH3. Alright, and everything is green, so I know I did that correctly. Great, excellent practice. So then that's a moles to mass problem, like last week. So then let's do another one. This one is like the second one here. This is a grams to moles problem. So this is like this week's problem. So 125 grams of chromium 3 sulfate, and it says chromium 3 sulfate is Cr2SO4 this one right here. So first thing I need to do is balance the equation. I see that I have 2 CRs right here and only 1 on this side. So I'm going to type a 2 in there. And then I have now 6 NO3s, and over here I only have 2, so I'm going to need to put a 3 right here to give me 6 NO3s. And then CAs, I have 3 right here, so I'm going to need to have to put 3 here to give me the 3 CAs, so that matches. And then I have 3 SO4s, and then I have 3 SO4s, and CR is 2, and CR is 2, so I just put a 1 here, and that is balanced. Alright, so the next step is to find the molar mass, and I have CaNO32. So you find Ca, you find N, you find O, and so Ca is 40.08, and then add that to nitrogen, which is 14.01, but it was times 2 because there's a 2 outside the parentheses, and then add that to oxygen, which is 16 times 6 because of the 3 inside and the 2 outside. So 164.1. 164.1. Alright, so then CrSO4 so Cr is times 2, you go to the periodic table, chromium is 52, so that's going to be, clear that, so 52 times 2, and then add that to S times 3, so S is 32.06, 32.06 times 3 is 96.18, and then O times 12, because there's 4 here and 3 there, so that would be 16 times 12. Alright, so I'm going to add all these numbers I have here on the side together, so 192 plus 104 plus 96.18. 392.18. Alright, so the next one is CaSO4, so Ca plus S plus O4. So Ca, calcium is 40.08, and then, 40.08, and then add that to S, and S is 32.06, and then O4, so that would be O times 4, which would be, add that to 16 times 4, and that would be 136.14. So then the next one here, CrNO3, so Cr, go back to the periodic table, I think that was 52 plus N times 3, which would be 14.01 times 3, and then add that to O times 9, 16 times 9. 238.03, 238.03. So then we're done with our molar masses. It's a little bit time consuming, but again, it's pretty good practice. So now let's do the actual problem. 125 grams of chromium 3 sulfate, which is this one, the Cr2SO4, this one, 125. So let's go here, write that out, 125 grams of Cr2SO4 first division bar. So this is like the problem you learned just in the last assignment, just this week. So the grams of CR2 SO43 on the bottom. It's kind of long. And then that's going to always pair with moles. Grams always pairs with moles of the same thing. CR2 SO4 3. Moles is always 1 when paired with grams, and then the mass, we already found it. So CR2SO43 is 392.18. 392.18. Alright, second, take your starting unit and put it on the bottom. So this would be moles of CR2 SO43. And then the top unit is what they asked you for, so it would be moles of calcium nitrate, and calcium nitrate is this one, CaNO32. So moles of Ca, close parentheses, or open parentheses, NO3, 2. Moles over moles, so go to the equation to get those answers. This has a 3 in front of it, and this has a 1 in front of it. So this one would be 3, and this one is 1. And then you use a calculator to solve. 125 divided by 392.18, and then multiply by 3, divide by 1. So I'm just going to do the multiply by 3, and 1 will give us the same answer. So let's say 0.96. So let's transfer over. We'll start with this, so that should go in your first drop down, the 125 grams of this, and then your next unit here on the bottom was the 392.18 grams of CR2SO43, and they have a slightly different number here, no big deal, it's just rounded slightly differently, whatever. 392.21 is what they have, but it's through the 392.18. And then on the top was moles of the same thing, so 1 mole of this one. And then the next division bar on the bottom, it was 1 mole of the starting unit. And then the top was the 3 moles of the CaNO32. Alright, and then the answer we calculated was 0.96. Alright, and then the last thing is units. So this top unit is the final unit, moles of CaNO32, moles of CaNO32. Alright, and the whole problem is green. So that's how you do that. You know, it's a fair bit of work, but if you remember that the steps are basically consistent depending on, you know, it doesn't matter what kind of problem it is, you kind of always do the same thing, then that makes it, you know, more easy. So again, this is mixed. Some are grams to moles, some are moles to grams, but those problems are pretty similar to each other.